So, welcome back. We were talking about the Doppler effect, which was explained in 1842 and tested in 1845 by Bose Memorial. And I told you that there are three separate situations which we discussed in the other lecture qualitatively as to what will happen to the frequency which is observed by the observer in one situation where the source is moving and the observer is stationary, in another situation when the observer is moving and the source is stationary, and in third situation when both of them are moving. And of course in all the situations we consider the medium velocity to be equal to 0, and that is the medium is at rest. Okay, I'll tell you what to do with the medium velocity later. Now, let us have the source emitting out a wave having an angular frequency omega and a time period t naught with respect to the medium, okay, with a speed which is equal to v meters per second. Okay. We assume that the observer has a detector, can be here, can be some other instrument, has a detector that is a counter that counts every time a crest reaches it. Okay. So initially the source is at S1 at the time t is equal to 0, and it emits a crest. Okay, the distance between S1 and O is equal to L. Okay, the crest reaches the observer in time t1, which is equal to L divided by the velocity with which the wave is traveling. It doesn't know what's going to happen next. Okay, but the source is moving with the velocity Vs away from the observer. Okay, so at t is equal to t0, the time of the wave, the time associated, the source has moved from S1 to S2, okay, which is distance equal to Vs into t naught, and the distance from here to here becomes L Vs t naught from the observer. Okay, it's very simple, no problem. When at S2, in this location, new location, the source emits the second or the next crest, okay, which reaches O at a time, and that time is t2 is equal to t0 plus L plus Vs t0 divided by the velocity. It's not difficult to understand. So this is the relation at which we'll ask you to ponder, to think, and you will arrive at it. It's a very simple logic. So next we can have a time t3 which is equal to t0 plus L Vs into 2 divided by v. Okay, because the distance traveled now becomes more. So that way, crest number 1, crest number 2, crest number 3, crest number 4, crest number n. Okay, when the time that elapses is equal to nt0, the source emits the n plus 1n. Why? Because at time 0 it emits the first, at time capital T naught it emits the second, 2t naught, third, so it emits the n plus 1th crest that reaches the observer at a time which I will call as Tn plus 1 is equal to Nt naught plus L NVS T naught. Here that change will be there, divided by V. Okay? So from there we proceed. So we found that Tn plus 1 is equal to Nt naught plus L NVS T naught divided by V. Okay. So now if I subtract the time interval L upon V from this time, okay, Tn plus 1, so it will say that this minus this is equal to, you can see L upon V and L upon V will cancel out, you will get Nt naught N Vs T naught divided by V. Okay, so we obtain this relation, which if I take Nt naught as common, I will get the time interval equal to 1 plus Vs upon V. Now what happens in this time? In this time the detector at with the observer counts n crests, okay, and records the period of the wave t given by this whole thing divided by n. Okay, so this period which is recorded by the detector, it turns out to be equal to t is equal to t naught 1 plus Vs upon V, and because t is equal to t into nu, okay, is equal to 1, this is the relation, or nu is equal to 1 upon capital T, whatever. So if we inverse that, I'll get 1 upon T is equal to 1 upon T naught and into 1 upon this whole thing, which I can write as easily, you are intelligent people, nu is equal to nu naught 1 plus Vs upon V raised to the power of minus 1. Now this Vs is very, very small as compared to V, the velocity of sound. Okay, therefore I can write this as, by the binomial this thing, nu naught 1 minus Vs upon V. Okay, because the expression is 1 plus x raised to the power of minus 1 is equal to 1 minus x. Okay, in that expansion, when x is taken as very, very small as compared to 1. So now I write this equation over here. Nu is equal to nu naught 1 plus Vs upon V. So you can see that the source is going away from us. Okay, so Vs upon V is a positive thing. Okay, and 1 minus Vs upon V is less than 1. So nu is more than, okay, I'm sorry, it is less than nu naught. Okay, now here I write that suppose the source is moving rather in this direction, so the velocity will be counted as minus Vs. So I put here in this relation nu naught this like this. Okay, so the observed frequency by the detector becomes equal to nu naught 1 plus Vs upon V. Okay, now remember, if the source is approaching us, then the frequency observed must be more. If it is going away from us, then the frequency observed will be less. And if that you bear in mind, then I can write a single equation here with a nu is equal to nu naught 1 minus plus Vs upon V observer. So bear that in mind, that we'll get a single equation like that. Okay, next we are putting the source is stationary and the observer is moving and the medium is at rest. So in the next set we set the source stationary and the observer moving. Medium velocity we take as equal to 0. Okay, that is, it is at rest. Oh, sorry. This expression that I obtained called for removing this 0 from here, the velocity of sound is v. Okay, so please make corrections. Nu is equal to nu naught 1 minus plus Vs upon V0. Okay, and you have to choose properly. If the source is moving towards the observer, then the velocity will be, the value will be increased. Else, if it otherwise, then it will be otherwise, and it will, okay. So now in this case, we have the observer moving towards the source with the velocity v naught. Oh, v observer, not v naught. And the wave approaches observer with the velocity v plus v0, because that will be added to it. So for the nth crest, we'll have a value of t as t n plus 1, and for the first crest, I will have t1. So the time interval between the two of them, tn plus 1 minus t1, okay, this will, like before, will come out like this. Nt naught minus nv naught t naught upon v naught plus v are the observed period that will turn out to be equal to this thing, this time divided by n, because n crests have come there. Well, by the way, we can take troughs also at the same condition, no problem. So instead of taking the crests, we can take troughs up, but keep it to crest only, because else you get confused. So n and n cancel out. I'll get it as t naught 1 minus v0 upon v0 plus v, and when I multiply it here, and the whole thing will become equal to v0 plus v minus v0 whole thing divided by v0 plus v. Okay, so I can put here like that, and then we get this t0, okay, and v plus v0. So t is equal to t0, and divide it up and down by v, I'll get 1 divided by 1 plus v0, vo, observer, upon the velocity of the sound wave. So this turns out to be equal to, now I can write it, this is in the denominator, so this comes 1 plus v naught upon v raised to the power of minus 1, which will turn out to be equal to t0, 1 minus v naught upon v, using the identity that 1 plus minus x raised to the power of minus 1 is approximately equal to 1 minus plus x, in case x is very, very small as compared to 1. Okay. So with that, now let us say that in terms of rather frequency. So the frequency is equal to 1 upon time period. So nu will become equal to 1 upon, nu will become equal to nu naught, and whatever result I have got here, that has to be inverted. So 1 minus v naught upon v raised to the power of minus 1. We apply it again over here, this kind of a identity, and what we find is that this turns out to be equal to nu naught, the original frequency, 1 plus v0 upon v. So naturally, because we took the observer moving towards the S with the velocity v naught, so that the frequency here enhances. Okay. Now, if v naught is going away from S, okay, then we can write this as equal to instead of plus v observer, will now write minus v observer. So I obtain the relation for the source observer moving away from the source. I'll get this relation. These two relations can be combined here. Nu is equal to nu original. Okay, the frequency nu naught 1 plus minus v0 upon v. Okay, now we can see that if the value of v observer is small, then the Doppler shift, any change in the frequency, observed frequency minus the original frequency, will be almost the same as in the other case where we established that this is like this. Next, we take the case when the observer and the source both are moving. So the last item for this lecture, and also that completes the course for class 11, is the third situation when both the observer and the source are moving. I've just taken an original position of the observer and original position of the source, O1 and S1 respectively. And after that, the wave has got the velocity v, frequency nu naught. Okay, we take it nu naught, right? And so t naught is the time period of the original wave. The observer has got a detector here, and this situation I have just taken. The observer is moving towards the source, and the source is moving away from the observer in the same direction. So these velocities are treated as positive. Okay, both these velocities are taken as positive, right? And here O is taken to the left of the source. Okay. Anyway, there could be another situation which I leave it as an exercise for you and must be done, that you keep the observer to the right and the source to the left. Okay. Well, both are moving either away or towards, but in this case both are moving in the positive sense, and V0 and Vs, VO and Vs are both positive. Say, okay. O is to the left of the source observer. Crest is emitted at the time t is equal to 0. Distance between the two of them, the source and the observer, that instant of time t0 is equal to L. Okay. The velocity of the wave related to the observer is v plus v observer, and the first crest reaches at time t1, which is L, the distance, divided by this new velocity v plus vo. Okay. Now O moves in this time t1 to O2, and S moves to S2 from the original position of S1. So there is a new distance hereinafter between O and S, that we say O2 S2, between these two. Okay. The velocities appear here to be almost the same, but they can be different, and you can draw like that. You can scribble whatever velocities you want. Okay, less or more doesn't matter. At S2, the source emits the second crest when it is here at S2. This reaches the observer, the detector at a time t2, which is equal to t0 plus, okay, I can take it like this, L Vs minus Vo upon V plus Vo. So there is now, if we talk about the nth crest reaching there, then the time t n plus 1, that will be equal to n t naught plus L plus n Vs minus Vo divided by V plus Vo. Okay. So this interval, this minus t1 will turn out to be like this. The whole thing minus L upon V minus V0. Okay. So n crests are counted. In time t, if we work it out, then this turns out to be equal to t is equal to t naught 1 plus Vs minus Vo divided by V plus Vo. And when I take the LCM etc., then I get this, will turn here V plus Vo plus Vs minus Vo. So this turns out to be equal to T0 V plus Vo Vs upon V plus V0. If we now write from here the frequency, the corresponding frequency, so I get 1 upon t, 1 upon t naught, 1 upon this whole thing, okay, and this works out to be equal to, okay, nu is equal to nu naught, the real frequency with which the sound is emitted, V plus Vo divided by V plus Vs. Okay. Now, if you have to think as to what will happen if either the source or the observer is going towards the other one, then in that case the value will enhance, the frequency will enhance, and if it is going away from that, then the frequency will be reduced. Accordingly, you can put the negative sign here and the negative sign over here. Okay, you can see, let's take the negative sign away. One interesting situation is that if the velocity of the observer and the velocity of the source are the same, then this turns out to be equal to 1. So nu becomes equal to nu naught. This is the situation I told you when you are sitting in a train or a bus and there is a musician and both of you are moving in the same direction with the same speed, then you get a thing like that. Even if the train is moving in the reverse direction, then the same. Okay. So this is how I remember this formula for the Doppler shift. Doppler shift is nu naught minus nu. Okay, the change in the value. But I'm concerned right now as to what is the new frequency, the Doppler frequency that will be there, and it is obtained like this. How do I remember? I remember that there is a V plus another velocity and V plus or minus another velocity. The velocity of the observer and the velocity of the source. How do I remember which is in the numerator and which is in the denominator? I know that in the alphabetical order, O comes before S. Okay, so don't get confused. Remember only this equation, and from this equation we can obtain the other two equations that was there. Okay, so with that we come to an end of this class 11th course. And already when I was describing the qualitative things, then I told you how this is used, red shift, blue shift. Even in the case of light or other electromagnetic radiations, this Doppler effect not Doppler's effect. It is such a strong effect that we don't like to call it Doppler's effect. We call it straight away Doppler effect, as if this is a phenomenon all by itself. This is a very interesting situation, the Doppler effect. In all kinds of wave motion, there are shifts, there are, that is, if the galaxies are moving away or they are collapsing, what is happening, what will be the velocity of one star with respect to a constellation, etc. And also, in the case of ultrasound and sonography, Doppler shift is used to determine many physiological and medical things that you can have. So, let's say, good that we have finished the class 11th course. Of course, there is one thing, that in all things that I have taken, I have explained to you as much as I could, or I have given you the knowledge that I have, and I am going to tell you again that, friends, you didn't help me, but whatever knowledge I have today is 20% only from my training, from my teachers, from my colleagues, from my research, from my discussions. There used to be no webinars in those days, so seminars, etc. But 80% of whatever I know is from my dear students. So you want to be 80%, or you want to give me a chance to be with the 20% only? Thank you very much. Okay, I hope that you ask tough questions, not only to me, but to all teachers, because all coaches, everybody, you come, and particularly who you are supposed to question and to obtain a proper answer, it is your person itself. And second is your colleagues of the same level, whom you can say, yaar meri samajh mein nahi aa raha hai, brother, Paul, how is this done? I'm in a fix. Okay, they will never mind, because there is a saying in Urdu that hammam mein sabhi nange. Okay, so you're all naked in the washroom. So don't worry. Don't you ever think that you don't know and the other one knows. He also doesn't. He may know something, but he may not know other things. So cooperate, and that way you can go ahead. So the new beginning, the new door is class 12, and I'll talk to you next about the charges and the properties associated with charges. So long, see you.